Hey, welcome back. This is the video for Unit 7. This unit has 3 lessons, so it should take you about 3 weeks. And this unit is all about Earth's changing surface and the different landforms that might occur on Earth's surface due to those changes. Here's our essential questions for the unit. What processes lead to the development of different landscape features, such as valleys, mountains, and plateaus? What factors on Earth's surface affect how landscapes evolve? And how do Earth's internal processes affect features on Earth's surface? Okay, let's get started. All right, so our big vocab words for this unit are weathering and erosion, and there is a difference between the two. A lot of times we get confused because we talk about weathering and erosion in the same sentence. Like we think they mean the same thing, but they don't. Weathering is actually the process that breaks down rocks. We take a bigger rock and we make it smaller. We turn it into smaller pieces. And that can happen through a variety of processes. Erosion is the transport of those rock materials from one place to another. So a lot of those processes that both weather and erode sediment are the same, but the actual words mean different things. Weathering is the breakdown and erosion is the transport. So keep that in mind as we move through those units. Those are words that we're going to see over and over again. Okay, there's 2 types of weathering. So remember that weathering is the breakdown of rocks. We can get mechanical weathering or we can have chemical weathering. Sometimes you might hear me refer to mechanical weathering as physical weathering. Those are the same thing. Mechanical weathering is just breaking one rock physically down into smaller pieces. So if you Hulk smash a big rock and now you have sand, you've just mechanically weathered it. In chemical weathering, that's when you're using some sort of chemical reaction to break down rocks. So if a rock is dissolving, if it's rusting, if there's acid rain involved, all of that is considered chemical weathering. So with mechanical weathering, we're not changing the chemical makeup of the rock, but with chemical weathering, we are. Some sort of reaction is occurring. So here's a couple examples of mechanical weathering. And notice in the picture, we had one big rock, we split it in half, right? That's mechanical weathering. So probably the most common type of mechanical weathering is abrasion. So it's kind of the slow and constant wearing down of rock over time. So wind is really good at abrading a surface, right? If you have wind that's carrying sand particles, that sand will constantly rub up against a rock outcropping or something, creating interesting shapes. If you've ever been to arches in Utah, those are all formed by wind abrasion. But glaciers can also abrade. Sand in a river can cause abrasion. So it's a really common method of weathering. Freezing and thawing is an important one that comes up a lot, especially in climates like ours, where you get a lot of back and forth between freezing and thawing climates, right? So imagine that during a warmer period, you get water getting into the fractures and the cracks in a rock and then freezing. And when water freezes, it expands. So that expanding ice pushes against the sides and makes those fractures larger. Then you melt, you infiltrate more water into the fractures, freeze again, and you make your crack slightly larger again. And so this back and forth between freezing and thawing causes ice wedging, and these rocks eventually break. So that's probably what happened to the rock in that picture. If I had to guess, that was freezing and thawing. But we can also get animal action that causes weathering. Any sort of burrows can cause weathering, and plant growth can cause weathering as well. Plant roots in the ground really can break up rocks. We've seen that happen in sidewalks all the time with tree roots. So that's a common form of weathering as well. Some examples of chemical weathering. I mentioned acid rain earlier. Acid rain happens when pollution in the air mixes with water and you get slightly acidic rain falling that might dissolve rocks. Carbonic acid forms when limestone or calcium carbonate, that's the same thing, a fancy word for limestone is calcium carbonate. When water dissolves calcium carbonate, it creates carbonic acid. And it's a pretty weak acid. It's the same type of acid that is in your soda products, if you drink soda. But this acid can dissolve rock. So that's how we get caves, is when calcium carbonate is dissolved. Living organisms, plants can produce sort of a weak acid that will also dissolve surrounding rocks slowly. And oxygen is a big one. Oxidation is the process that produces rust. So any sort of rust is considered chemical weathering. So rocks that have iron in them will often start to turn orange over time, and that's a chemical weathering process. So weathering happens at different rates depending on your climate and where you are on the planet. So remember, climate is the overall weather condition of the area. It doesn't have anything to do with the current weather. It's just the general average conditions. So weathering will depend on climate, and it also depends on the type of rock. Some rocks are more resistant to weathering than others. And just so you are aware, warmer climates tend to weather faster because there's lots of water in the air, lots of water on the ground, and that tends to speed up weathering. So warm, wet climates will have a faster rate of weathering. Cold, dry climates will have the slowest rate of weathering because you just have less water and wind happening, and a lot of times less rocks visible for weathering. Okay, so soil formation. Over time, rocks are going to weather. You've got solid rock, and that will weather down into sediment and pieces of rock, and plants might start to grow in there. And you might get air and water and some dead plants and organic material and maybe some mushrooms growing in that. And eventually, what used to be this solid rock will evolve into soil. Soil is a mixture of rock particles and minerals, decaying organic material, air, and water. And that is really what allows plants to grow readily. And it's kind of an evolution from solid rock to really healthy organic soil. Soil formation happens over a long period of time. And as I said before, it's kind of an evolutionary process. So as soil is forming, it forms these different layers. And we call those layers horizons. So topsoil is the A horizon. It's the very top layer, crumbly, dark brown. That's where lots of your organic material is. And then subsoil is your B horizon. That's going to be below your topsoil. So it's got less organic material, probably more clay. It's a little harder. But there is some still critters and things living in that subsoil. And then the C horizon is the bottom layer of your soil. You're going to have some larger rocks in that layer because it's still partially weathering. So moving on from soil, we're kind of like change directions again. We're going to talk about how water can erode and deposit. So transporting sediment and depositing that sediment back down in other places. Water is one of the most common agents to transport sediment, right? It happens a lot. Rivers, lakes, ponds, all of those things are going to act as erosional agents. A couple of landforms that can form because of water erosion and deposition. Waterfalls, obviously, that's a pretty obvious one. Floodplains are wide, flat areas of land along a river where if that river were to flood, that water will hang out. Meanders happen when rivers slow down to a pretty slow rate. So when a river is flowing in a mountain, it's going to be flowing quickly, like in our picture there. And it's not likely to bend a lot. It's going to just flow straight downhill. Whereas when you get to a flatter section of a river's path, it loses a lot of energy, it slows down, and that's when you'll start to get these really wide meanders, these big bends in a river. And over time, those bends become larger and larger, and they may even move a little bit and cut off from the major river path. And that's when we get these oxbow lakes. So they used to be part of the river, but they've been cut off as the river has changed course over time. And then deltas are super important. They come up a lot in this unit. Deltas occur at the mouth of a river when it flows into an ocean or a lake. That water is moving and all of a sudden it comes to a stop. So it loses energy and it drops all of the sediment that it's been carrying right at the mouth of that river. So you end up with a triangle shape of sand and silt and stuff that has been dropped right in the mouth of that river. So we've so far talked about lakes and rivers. Those are super important surface water features. And those are the ones we're most familiar with because they are on the surface. We can see them. But the majority of water on Earth, the fresh water on Earth, is found underground. It's called groundwater. And when we think of groundwater and aquifers, oftentimes we think of these huge underground caves that just store water for us. But instead of that picture, I want you to think about groundwater as a sponge, right? It's actually just rock down there, and that rock is saturated with water. So that sponge is saturated. There's no big giant cavern that stores all of our water, right? So think about that when we're talking about aquifers. But caves do happen, right? Caves occur on a small scale when limestone is dissolved by water. And when that calcium carbonate is dissolved, you end up with a lot of calcium carbonate dissolved in the water. And that can be redeposited back into the caves as stalactites that hang tight to the ceiling and stalagmites that you might trip over. So those are the ones that are on the cave floor. So again, all those are redeposited calcium carbonate. So moving from freshwater to our saltwater, waves definitely cause coastal erosion, right? You might have some areas where the waves are depositing sand, but a lot of times those waves are eroding whatever is around them, carrying that sediment deeper out into the sea. So waves are a huge source of abrasion over time, and they form that really nice rounded sand particles that form our beaches. So beaches are depositional landforms. They're formed when waves will deposit sand over time. So moving on from water altogether and thinking about wind. Wind causes erosion mostly by abrasion or deflation, where wind is removing particles. So you get dunes is probably the most common landform that you're going to see by wind deposition, right? Something causes that wind to slow down or change direction, and it'll drop any of the sand that it's carrying in that particular location, and you end up with big piles of sand. Loess is less common, and you won't see that show up on your quiz, so focus on dunes. So a quick reminder about erosion. Erosion is the transport of sediment from one place to another, and that's affected by weather, climate, topography of a region, right? Mountains, valleys, all of those are important to wind erosion, and the type of rock at the surface. And deposition is the dropping or the laying down of eroded material. So usually you'll have erosion, that's the transport, and then deposition is what comes at the end. It's the dropping of the sediment. So if you're riding in a bus down the street, you get off at your stop, that would be deposition. Mass wasting occurs when you get a large downhill movement all at once of a bunch of sediment. And these are usually caused by gravity. So mudslides, landslides, you get a big amount of sediment moving downhill. All right, in glaciers, we need to talk about glacial erosion as well. So glaciers are large masses of ice that exist on the crust. So there's land underneath those glaciers. They're not floating on the ocean. And these guys can cause quite a bit of erosion. There's two types of glaciers that we're going to talk about. Continental glaciers are ice sheets, and they just kind of flatten and move outwards toward the ocean in all directions. So these are really, really big. Greenland and Antarctica are really the only ones that we have left on the planet. But we've got lots of smaller valley glaciers that change size seasonally. So these are the glaciers that will form up in the mountain valleys in the winter. They'll grow really big, and in the summer they'll retreat up the mountain a little bit. Both of these can cause erosion over time. So remember, we're still focusing on erosion here, and two processes that are going to cause glacial erosion are plucking and abrasion. There's our abrasion word again. So plucking is when a glacier is flowing over land and it'll pull entire rocks straight out of the ground. So you'll get these pretty sizable boulders just picked up and carried by the glacier. So plucking is a pretty appropriate word for that. And then abrasion is kind of just wearing down that valley floor over time. So like really sandpapering it smooth. So you get these like scratches that occur in the rock all the way down where the glacier was moving. So do remember that glaciers do involve movement. They're not just stationary. They're growing bigger, they're retreating, they're moving outward. So that movement is what's causing the erosion over time. And here's a couple of landforms that are depositional, meaning they're formed by adding sediment. So till is a mixture of sediment deposited directly on the surface by a glacier. It's usually poorly sorted because it's got all different sizes of sediment in there. Glaciers just pick up whatever they come across, and they don't sort by size or anything like that the way water or wind might. A moraine is a ridge formed from till that will signify the edge of a glacier. So a lot of times in the winter, as the glacier is growing, it kind of bulldozes a little mountain of sediment along the front of it with it. And when the glacier retreats, it'll leave that mountain of sediment there where the glacier ended, and that's a moraine. And a kettle is a small depression that forms when a chunk of ice is left behind. So it is just like a little baby lake left behind by a chunk of glacial ice. We've got quite a bit of those in Wisconsin. That's where the Kettle Moraine State Park name comes from. All right, I feel like I had something else to say about glaciers, but I don't remember what it was. So we'll just move on. Oh, I remember. Hang with me. So valleys that are formed by glaciers can look different than the valleys that are formed by water. So both flowing glaciers and flowing water can form these valleys over time because they're eroding sediment away. But a valley that's formed by a river, which we call a canyon, is much steeper sided and forms a V at the bottom with the river running through it. So V-shaped valleys are formed by water. Glaciers are much more massive, they're much wider. So the valleys that they form are more shaped like a U. So U-shaped valleys signify that it was formed by a glacier. Okay, so this is kind of harkening back to our talk about plate tectonics last unit. But continental margins are just areas where continental crust meets oceanic crust. So shorelines are the same thing as continental margins. And those margins come in two flavors, if you will. An active continental margin is a shoreline that is right at a plate boundary. So you're going to get lots of volcanoes, earthquakes, and mountains at an active continental margin. At a passive continental margin, that's a shoreline that is not at a plate boundary. So that's going to have more gradual rolling hills and no volcanoes. So, for example, the Pacific coast of the United States is an active continental margin. The Atlantic coast of the United States is a passive continental margin. So there's lots of volcanoes and earthquakes on the west coast and very few of those on the east coast. So faulting is something that will occur at an active continental margin where there's some plate motion happening or some reason for motion to occur. And they can either occur at convergent boundaries or divergent boundaries. So what's happening here with our reverse fault, if you'll notice, those two blocks are getting crunched together. That's happening at a convergent boundary, right? So you get the hanging wall is above the foot wall here. So reverse faults occur at convergent boundaries with compressional forces. They're being squeezed together, okay? Normal faults happen the other way at divergent boundaries with something called a tensional force, right? They're being pulled apart, so they're slipping this way. And then strike-slip faults occur at transform faults. You get the sliding past each other. So these different types of faults occur at different plate boundaries. If the deformation is happening deeper in the earth or at a different type of boundary, you might not get faulting. Faulting happens with really brittle rocks. You might instead get folding that will occur. And folding will give you something that looks more like this. Instead of the rocks breaking, they'll bend. And when they're bending downwards, here like on the left, you get a syncline. So syncline is kind of like a smiley face. That's how I remember it. Those layers are bent upwards. And then here in the middle is an anticline. They're bent downwards. And so eventually those will erode and we'll only just be able to see the slightest bit of a bend, but we know that there has been a fold here and we can extrapolate that outward. A lot of times these synclines and folding happens when a large glacier is present on land. When the glacier is present, it adds a lot of weight and it'll actually cause the crust to sink a little bit into the mantle. And then when that glacier melts and is gone, that mantle will push the crust back up and you get this rebound that's occurring, which can cause folds that look like this. So I think that is the end of our overview for Unit 7. You will have to do a little bit of extra research into one type of landform at the end of your guided notes. So be prepared for that. You'll have to do some outside research for this one. But I hope you enjoy it. I hope you learned something new. Have a great day. I'll see you next time.